aquaculture, the propagation and husbandry of aquatic plants, animals, and other organisms for commercial, recreational, and scientific purpose. Aquaculture is an approximate aquatic equivalent to agriculture, that is the rearing of certain marine and freshwater organisms to supplement the natural supply. This includes production for supplying other aquaculture operations, for providing food and industrial product, for stocking sport fisheries, for supplying aquatic bait animal, for stocking fishing operation, for providing organism for ornamental purpose, and for supplying feedstock to pharmaceutical and chemical industry. This activity can occur worldwide. Zooplankton are an important food source for many species of fish. They can provide an inexpensive alternative to other commercial feeds. Zooplankton have several advantages, among them a faster growth and greater feed efficiency for some species. The flavor and texture of fish are also improved with zooplankton as feed. Fish meal is recognized by nutritionists and as a high quality, very digestible feed ingredient that is favored for addition to the diet of most farm animals, especially fish and shrimp. Fish meal carries large quantities of energy per unit weight and is an excellent source of protein, lipid, mineral, and vitamin. There is very little carbohydrate in fish meal.
For problem statement, the evaluation of zooplankton's community and growth in UIT Muka is essential because zooplankton serve as key indicators of aquatic ecosystem health and contribute significantly to nutrient cycling and food web. However, rapid land use change and human activities around the campus may threaten this community. Yet, no comprehensive baseline data currently exists for this location. Previous research in Malaysian aquatic system has shown that zooplankton diversity and biomass are closely linked to environmental conditions and can reflect ecosystem disturbance. But studies specifically to UIT Muka freshwater habitats remains threat. The absence of such data limits the ability to monitor ecological change and implement conservation measures, potentially leading to biodiversity loss and destroy ecosystem service within the campus and surrounding area. Despite the recognized importance of zooplankton as bioindicator, there is a research gap regarding their community structure and growth dynamic in UIT Muka unique environment, which include peat swarm origins and proximity to plantations and tropical forests. Therefore, this study aims to assess the zooplankton's community composition and growth pattern in UATM Muka to establish baseline ecological data that will support environmental monitoring and sustainable management of the campus aquatic ecosystem. And for research objective, we decide to evaluate the potential of fish meal as feed supplement for zooplankton's community composition in the study area. For hypothesis, fish meal as supplement will increase the population of zooplankton community composition. Nonce. This has no differences in the population of zooplankton's community composition if doesn't use fish meal as feed supplement for zooplankton growth. And for alternative, this has major differences in the population of zooplankton's community composition if the use of fish meal as feed supplement for zooplankton growth. evaluation of zooplanktons community and growth, such as rotifer, copepods ammonia in UATMUK. For research question, how does fish meat as food supplement enhance the population dynamic and growth rates of zooplankton species in UATMUK?
So, I will explain the significant research of zooplankton. There are 4 significant research. First is introduction to the topic importance. Second is state the problem object. Third, explain who will benefit. And the last one, show how it contributes. The first one is introduction to the topic importance. Zooplankton are fundamental component of aquatic ecosystem and play an important role in aquaculture. They serve as primary consumer in food webs, providing a direct nutritional link between primary producer, algae, and higher trophic level, including economically important fish species. In aquaculture, the availability and quality of zooplankton can directly influence the growth, health, survival of fish, larvae, and juveniles, which are often the most vulnerable stage in fish production. Second one is state the problem or gap. Despite their recognized importance, there is limited localized research on the composition, population dynamics, and growth potential of zooplankton groups, rotifer, copepod, and moina in specific environment context of UiTM Sarawak. Additionally, the potential of fish meal as a feed supplement to enhance zooplankton growth and consequently the fish productivity in the region remains unexplored. This gap is significant because optimizing zooplankton production could reduce reliance on expensive commercial feeds and improve sustainability in local aquaculture operations. The third one is explain who will benefit. First, aquaculture farmers. Improved understanding and management of zooplankton communities can lead to enhanced fish growth, better feed conversion, and reduced feed costs, directly benefiting local fish farmers. Next, research and students. The finding will contribute to the science knowledge base, supporting further research and education in aquaculture and aquatic ecology. The last one is policymaker and industry stakeholder. Data-driven recommendation can inform sustainable aquaculture practice and feed formulation strategies, supporting food security and economic development in aquaculture industry and beyond. And the last one is show how it contributes. This research will provide baseline data on this diversity and growth rates of rotifer, copepod, and moina in UiTM aquatic system. Evaluate the effect of fish meal supplementation on zooplankton population dynamic, offering practical insight for optimizing live feed production in hatcheries. Support the development of cost-effective, sustainable feeding strategies by exploring potential of replacing commercial fish meal with locally produced zooplankton, which has been shown to enhance fish growth, immune response, and overall health in multiple studies. And the last one is to address a critical knowledge gap by focusing on the local context, enabling site-specific recommendations that are more likely to be adapted to practitioners. By advancing the understanding of zooplankton ecology and their role in aquaculture, this research will contribute to more resilient, profitable, and sustainable fish farming practice in aquaculture industry, with potential applicability to similar environments as well.
Aquaculture industry. Currently, the aquaculture industry is the one of the fastest growing food production sector of the world, supporting to meet the increasing demand for aquatic products to reach 10 million human population by 2050. Giri SS 2034. In the light of the fact that wild fisheries are overexploited, aquaculture offers a sustainable alternative for protein-rich food and essential nutrients like omega-3 fatty acid that are vital for human health. Giri SS 2024. The industry is that of fish, mollusks, crustaceans, and aquatic plants, which make them a way adapting to environmental conditions and they share less vulnerability to climate change than traditional agriculture. Since the 1096, there have been much progress in the aquaculture sector. A study conducted by Stanford University, also involving the University of Stirling, say that over the past 20 years, the industry has become more and more sustainable. The evidence of the progress is evident in the use of environmentally sound system and increased emphasis on the economic viability. Although, the study also stressed the requirement of more effective oversight and governance to achieve the sector's promise in delivering to global food and nutrition security. Aquaculture generally depends on zooplankton during larva rearing stage of the fish and crustacean. They offer a very high nutritional life feed that enable quick growth and survival of aquatic larvae, unable to prepare artificial feeds in early stage. Such commonly used zooplankton groups in hatchery are rotifer, cladocerans, and copepod on account of their size, digestibility, and nutritional profile. Zooplankton are greater than many formatted feed in the term of essential amino acid, fatty acid, and micronutrients, and are woefully superior for the growth and improved feed efficiency and culture species. Microbial and algal proteins. The recent breakthrough employ single-cell protein (SCP) made from microbes or microalgae cultivated using food processing wastewater. For example, the scientists from Singapore replaced part of fish meal in essence sea-based diet with SCP from processing wastewater of soybean, delivering eco growth and more regular fish size. Also, marine microalgae co-products like nanochlorophylls or coletta have been tested in the form of the fish meal replacement in nine tilapia and have encouraged growth performance and nutrient digestibility. Although only a few number of studies on zooplankton communities have been carried out in Sarawak, Malaysia, especially in the UiTM Muka campus, numerous studies have been done on zooplankton communities in Sarawak, Malaysia. However, there are some interesting work having relevance to the diversity, abundance, and ecological roles of zooplankton, rotifer, copepod, and moina in different aquatic habitats in Sarawak. The result of the some zooplankton species, IL-45 species belonging to 30 significant group from the seagrass habitat Lawas, Sarawak, recorded in May 2016 to February 2017. Alburish MH 2021 grouped the total abundance were copepod 47.4% and bivalve 31.8%. During August and September, increase in relative abundance and important species in this included the copepod species Pavolacanus crassitosis, which have practically abandoned the study. The study concluded the zooplankton diversity and richness peaked during intermediate season due to the convergence of good physicochemical conditions and a biovariable including turbidity, nitrate, rainfall, dissolved oxygen, and pH, and important effect on zooplankton abundance. Alburish MS 2021. Identify study gaps. Lack of data from UiTM Muka. However, there are insufficient studies available pertaining to other parts of the Sarawak, Lawas, Miri, Sibu, and Lundu, as well as the lack of published work specifically from UiTM Muka. It fills a significant gap in the current knowledge of the distribution of zooplankton in Sarawak. Limited species growth assessment. Although copepod are frequently reported as dominant, only few organisms have been studied on rotifer copepod and moina. Population dynamic and growth rates in relation to environmental factors, particularly in artificial or managed water bodies such as those other potentially found within the UiTM Muka campus. Environmental parameter correlation. It has been established there are correlation between zooplankton abundance and parameters such as turbidity, dissolved oxygen, and pH at the other region yet not well documented in UiTM Muka. It is important to understand local ecosystem functioning as well as aquaculture management.